So here's an example of utilizing the problems in a lift. So a man of mass 80 kilograms is standing on some weighing scales inside of an elevator. What would the scales read if, firstly, if the man was at rest, secondly, if the man is accelerating upwards at 2 meters per second squared, the second one is if the man is accelerating downwards at 3 meters per second squared, and lastly, if the man is traveling upwards at a constant speed of 4,000 meters per second. So go ahead and try these problems yourself, and when you're ready, come back for the solution. So here's our man inside of the lift. If the lift is at rest, weight is just mass times gravity, which is 784 newtons. So that should be a relatively straightforward one. Now, if the man is accelerating at 2 meters per second squared upwards, he will naturally feel heavier because the elevator is almost like it's squishing onto the man. So the reaction force will have to increase, and therefore his apparent weight will increase. So using our formula, we get the weight, so mg, plus m times the acceleration in the lift. So that's 784 plus the apparent weight added, so that's 160. So his new apparent weight is 944 newtons. His apparent mass, in that case, he feels about 16 kilograms heavier. So in dividing the 944 by 9.8, you get about 96.3 kilograms. So his perceived mass is increased by about 16 kilograms. The third example, if they accelerate downwards, they feel lighter. So this would be 784 minus 80 times the acceleration in the lift. So that's 3. So you do 784 minus 80 times 3, so it's 240. So his apparent weight is 544 newtons. Therefore, his perceived mass is about 55 kilograms, so he feels roughly about 25 kilograms lighter. Lastly, if you read that carefully, it's a constant speed. No matter what the constant speed is, his perceived weight won't change. Now, obviously, getting up to a speed of 4,000 meters per second will cause him to feel very, very heavy. If you were wondering, if we'll do 784 plus 80 times 4,000, so let's say it happens in a second, he will have a perceived weight of about 321,000 newtons. So he is pretty much dead in that situation. But in magical physics land, where nobody dies, if it is somehow traveling at a constant speed of 4,000 meters per second, he will still feel his weight of 784 newtons, much like he was at rest.